So one of the things that we can do with our trig identities is we can verify that expressions equal other expressions. And so that's what we're going to do in this lesson. So whenever you're looking at an equation that has trig identities, if you want to verify the identity, first of all, you can only work one side of the equal sign. It's not like solving an equation where you can, multiply both sides or add both sides. You can't do that when you're verifying an identity. It's kind of like a proof. So you're only working one side of the equation. And I suggest you try to start with the most difficult looking side, the most complex side, because it's easier to manipulate that and get it down to something simpler. All right, so let's take a look at the first one. So we want to verify this identity, and we have cosecant squared of theta minus cotangent squared of theta over tangent squared of theta times cosecant squared of theta. So if you remember your Pythagorean identity, the numerator actually can become 1. And so then we still have tangent squared theta over cosecant squared theta. And we're trying to keep our end goal in mind, just like when we do geometric proofs. We know that we are trying to get the left side of the equation to be cosine squared of theta. All right, so now sometimes it's helpful to turn things into terms of sine and cosine. So we can turn tangent squared in the denominator. That actually can become cotangent squared of theta. So that way we get rid of the fraction. And cosecant squared of theta becomes sine squared of theta. Now I know we didn't turn it into terms of sine and cosine completely yet, but we're getting there. So cotangent squared of theta can become cosine squared of theta over sine squared of theta. And then what do you notice? You have a sine squared of theta in the top and a sine squared of theta on the bottom. So those will cancel out because those are equal to 1. And so cosine squared of theta equals, oh, look at that, cosine squared of theta. Wonderful. Okay, so then we have just verified that equation. All right, let's take a look at number 2. Okay, this one, it looks more challenging than it actually is. So the left side looks a little bit more complex than the right side. So let's manipulate the left side to try to get it to be the same as the right side. So we need a common denominator. So I'm going to multiply the first fraction by secant y plus 1. And then whatever we do to the bottom, we have to do to the top. And then the one on the right-hand side gets multiplied by secant y minus 1, secant y minus 1. Again, whatever we do to the numerator, we have to do to the denominator. And so our numerator, we're just multiplying those things by 1, so it becomes secant y plus 1 plus secant of y minus 1 all over. And then when you multiply those, notice that they're conjugates of each other. So it becomes secant squared of y minus 1. That is a difference of 2 squares. Okay. Now we can simplify the numerator. We have 2 of those secant of y's, and the 1's are going to cancel. If you notice, the denominator is a Pythagorean identity, so that is equal to tangent squared of y. Okay, and then we can change that tangent squared of y to cotangent because that tangent squared of y is in the denominator. So to bring it up, it becomes cotangent squared of y. And then we can turn them both into terms of sine and cosine. So secant is 1 over cosine. And then cotangent squared is cosine squared over sine squared. So again, notice we have a cosine in the numerator and a cosine in the denominator, so those will cancel out. And then we can do a little rearranging. We have 2, and then if we put a cosine of y over a sine of y, and then we leave one of those sine of y's by itself in that denominator, Now it becomes 2 times cotangent of y times cosecant of y, which is what we were trying to get to on the right-hand side. Okay, well, let's take a look at example number 3. And some of these will be a little bit longer than others. It really just depends on the problem. All right, number 3. To me, it looks like the left side is a little bit more complicated, so I'm going to go ahead and multiply. Actually, no, I'm not, because that'll make it more complicated. If you notice, we've got squareds and ones, so let's take a look at our Pythagorean identities, and maybe we can change them into something else. Cosecant squared of theta minus 1, well, that's the same thing as cotangent squared of theta, and cosine squared of theta minus 1 is equal to negative sine squared of theta. So that was helpful. So we didn't have to do all that multiplication. We could have, and we'd get there, but it might take a little bit longer. Then I'm going to turn my cotangent squared into terms of sine and cosine. So that becomes cosine squared over sine squared, because remember cotangent is cosine over sine, times negative sine squared theta. And notice you've got sine squared theta in the denominator and the numerator. So we still have our negative, and we still have our cosine squared of theta, and that is what we were trying to get to. So we have verified that one. Notice in all of these problems, I'm only working one side of the equal sign. I'm not working both sides. All right, let's take a look at example 4. Let's turn, well, first of all, the left-hand side is definitely more complex. Neither one of them is too complex, but the one on the left side is, so we'll work that side. So let's turn cosecant and tangent into terms of sine and cosine, because there's no squareds or anything, so we're not going to use a Pythagorean identity. But if we turn it into terms of sine and cosine, what do we notice? We have a sine in the numerator and a sine in the denominator, so those can cancel out. So we have 1 over cosine, and that is secant squared, which is what we were trying, I'm sorry, not secant squared, secant of x, which is what we were trying to get to. All right, let's try example 5. Now this time it looks to me like the right-hand side is a little bit more complicated, so we're going to work that side. Now we can't like separate anything, so we're going to do this one very much like we would rationalize. So in order to try to get a Pythagorean identity, possibly, we're going to multiply by the conjugate. And so we're going to multiply by secant of beta, that's what that b is, plus tangent of beta. And then whatever we do to the denominator, we have to do to the numerator. Okay, and so then we're just going to simplify that. I'm not going to distribute my cotangent. Well, actually I will distribute the cotangent, because when I multiply the cotangent by the tangent, that'll give me 1. So I am going to do that. So cotangent of beta times secant of beta plus cotangent of beta times tangent of beta becomes my numerator. And then my denominator, when I multiply that all out, I end up with secant squared of beta minus tangent squared of beta, because our middle terms are going to cancel out. That's why we want to multiply by the conjugate. All right, and then we can turn everything into terms of sine and cosine. That might make it a little bit easier. So cotangent is cosine of beta over sine of beta, and that's getting multiplied by 1 over cosine of beta. So there's my whole numerator. And then remember that cotangent times tangent is just 1. Okay, since it's cotangent of beta and tangent of beta, they are reciprocals of each other, and when you multiply reciprocals of each other, it just becomes 1. When you multiply reciprocals of each other, it just becomes 1. And then our numerator, that is actually a Pythagorean identity. So that is equal to 1. And so now we can do a little simplification. We know our cosines up here in the numerator, those are going to cancel out. So we're left with 1 over sine of beta plus 1, and then everything's over 1, so we don't really need to write that. And then the reciprocal of sine is cosecant. So cosecant of beta plus 1 is what we were trying to find. And so we have verified that identity. All right, let's take a look at number 6. Now this one we are going to end up working both sides, but it'll be okay. And I'm going to move this over here like that so we got a little bit more room. Okay, so we're going to start off by working the left-hand side. Yeah. All right, so we're going to hold off on number 6 for right now, and we're going to try example number 7. Actually, we're not going to do either one of those.